We're going to talk about sequences. So a sequence is like you have one number, comma, then another one, and so on. So it is an ordered list of numbers, okay? A sequence is an ordered list of numbers. And then what does it mean to say the limit as n goes to infinity of a sub n equals 8? That means that the terms approach 8 as n becomes large. Okay, so n going to infinity, it means n becomes large. And the terms approach 8. The terms approach 8, okay? Okay, so that's what that means. And then the third one, what does it mean to say that the limit is n goes to infinity of a sub n equals infinity? Okay, so again, as n becomes large, again, n becomes large, the terms become large. A sub n goes to infinity as well. So that's going to be this last one. The terms become large as n becomes large. As n becomes large. As n becomes large. Okay, so that's just a few things about sequences. We already know about limits of functions, and this kind of behaves similarly. And there's another way besides this of thinking of sequences. You can think of it as a function from the positive integers, or from the non-negative integers to the real numbers. You can think of it that way, where it's just the domain is just your integers, and then the range is just like any other function. So it's just like a function in that regard. But let's not worry about that. Okay, so let's I guess I got to scroll down this time. Okay, so let's do some examples of functions. I mean of sequences. So that's the first 5 terms of the sequence. Okay, so when we do these terms, some sequences start with 1, and if you look at the context of the problem, it starts with 1. So A1. So if you set n equal to 1, then that's a 1 right there. And 1's here and here. 1 minus 1 is 0. Negative 1 to the 0 is 1. And then so that's going to be 1/5. And then when n is 2, okay, basically just replace that with a 2, replace these with 2s. That's negative 1 over 25 will be the next one. And n equals 3. Then replace that with a 3, replace that with a 3. And this is negative 1 squared, which is going to be 1. And then 5 to the 3rd is 125. N equals 4. Negative 1 to the 4 minus 1 over 5 to the 4th. 4 minus 1 is 3. Negative 1 to the 3rd is negative 1. And this is 625. I used the calculator for that one. Okay, 5 minus 1 is 4. 8, negative 1 to the 4th is positive 1. And then you have 5 to the 5th, which is 3,125. Okay, any questions about that? Okay, great. This represents one of the two main ways of representing functions, which is as a formula. I mean, not functions, sequences, which is as a formula like this. So it's kind of like the same way that you usually represent functions. Number 3 represents the other main way of representing a sequence. This is, so here, so let me just say this. This is up here. This is a formula that gives everything. Okay, so, and just an explicit formula. What the? It's an explicit formula. And then down here, this is defined recursively. Okay. So A1 is equal to 1. No, I'm sorry, it's 7. A1 is 7. It just says right there. It says 7 right there, so it's 7. Oh, come on, stop. Hold on a second. Let me figure out how to get rid of that. In fact, while I'm at it, I'll go all the way back to there. Okay. Okay. So A1 is 7 because it says right. It says so right there. Now, to get A2, it's not like you're going to plug 2 into something. Okay. What you're going to do is you're actually going to set n equal to 1 in this formula here. Okay. So in this formula right here, when n is 1, you have 1 plus a sub 1 plus 1. That's going to be A2. It's going to be A1 over 1 plus A1. So A2 is going to be, and then A1 is 7. So it's 7 over 1 plus 7. That's going to be 7 over 8. Okay. So A2 is 7/8. Okay. And then to get A3, you set n equal to 2. Okay. And so setting n equals 2 here gives you A3 equals A2 over 1 plus A2, which is 7/8 over 1 plus 7/8. Okay, so that's 7/8 divided by, okay, this is going to be 8/8. 8/8 plus 7/8 is 15/8. So that'll be 7 over 15. Okay, and that's going to be A3. And then to get A4, you set n equal to 3. Oh, my goodness. Okay, so you set n equal to 3 to get A4, because that will make that a 4 there. And that's going to be A3 over 1 plus A3, which is this right here. So 7/15 over 1 plus 7/15. Okay, 1 is equal to 15/15. So 15 plus 7 is 22. So that'll be 22/15. Hopefully I can do this without making too many mistakes. The 15s cancel, you get 7 over 22. Okay, so that's going to be A4. And then A5, you're going to set n equal to 4 to get A5. And that'll be 7/22 over 1 plus 7/22, which is 7. Okay, this is 22 over 22. That's going to be 29 over 22. So that'll be 7 over 29. Okay, any questions about that? Okay, let's move on. Okay, number 4. So here it's kind of flipping the problem up on its head, whereas here we had a formula and we're supposed to try to find terms. Right here, they want us to find a formula for the general terms. Okay, so we want to, well, so yeah, so what we're after here is we want to find a formula. Okay, so here we want a sub n equals some expression where if you plug in the different values, if you plug in n equals 1, you get this. You get 6. When you plug in n equals 2, you want it to be 4. No, I'm sorry, -6 here. When you plug in n equals 3, you want it to be -8/3. And then n equals 4, you want positive 16 over 9. Okay. So maybe one thing you notice is that the signs alternate. Okay, so that's minus, that's positive, that's minus, that's plus, and that's minus, and that's minus. So minus, negative, positive, negative, positive, negative. Okay, now something happened up here where you had the signs alternating. This was positive, then negative, then positive, then negative, then positive. Okay, now, and it's because of this -1 to the n minus 1. Okay, now if we wanted to lead off with a negative, which is what this one does, then if we just throw in a -1 to the n, then that will do it. Because when n is 1, this will be negative, which is the first term. When n is 2, this will be positive. When n is 3, this will be negative again, and so on. Okay, so this right here will give us the alternating signs. So we just, for the rest of it, so all we have to do now is just worry about the rest of it, how to get the rest of it. Okay, so you want to get, so like you kind of look for patterns here. And here you see that there's a 2. This is 2 times 3, right? You can kind of see that. 6 is 2 times 3. 4 is 2 times 2. And then here we have 2 times 2 times 2 over 3. And then we have, here we have 4 2s and 3 squared. Okay, so you kind of see that. So you can see that the 2s are going 2 to the first power. And then here I could replace this with a 2 squared. And I could replace that with 2 to the third. Okay, so then I have 1, 2, 3, 4. Okay, so in looking at that, at this piece right here, if I put a 2 to the n, that covers that. Okay, now, and then finally, we have these 3s right here. Okay, so this is 1, that's 2. This is as if we had 3 to the 0. I can kind of see that pattern. And then right here I have 3 up in the numerator, but if I were to erase it and put it in the denominator, I could oh, I can adjust this. I can, they would be like this, okay? So 6 is actually 2 over 3 to the negative 1, because if I have a 3 to the negative 1 right here, then it comes to the numerator as a positive, as a 3 to the positive 1. Okay, and the 3 to the 0 is just 1, so that just goes away. Okay, so if I look at it this way, okay, so I've got, so if I divide by 3, now this is kind of offset because when you have 1, you actually have negative 1. So, but if I say n minus 2, then if I put a 1 in here, then a 1 minus 2 is negative 1. And when I put a 2 in, I get 0. And when I put a 3 in, I get 1, 3 to the 1. Okay, so this right here. So this right here will do it. And then you can double check. You just kind of put in, if you put in a 1 in here, you get, this is negative. Okay, which the first term is negative, and then I have got 2 to the 1, that's 2, and then 3 to, and then over 3 to the negative 1, but that comes up as 3 to the positive 1, which is going to give you 6, and so on. You can check with the other terms. Okay, any questions about that one? Okay, number 5. We're talking about convergence and divergence. We talked a little bit about it up here. Okay, and this depends on what happens as in every case, and you're looking at what happens when n becomes large. Okay. So in every single case, or for convergence or divergence, you're looking at that. So in other words, what happens when n gets large? Okay, and then for a lot of these, you can just think of so like here we're looking at this limit right here. But you could also compare it with the limit as x goes to infinity of 5 plus 7 x squared over x plus 5 x squared. You could think, okay, what happens as x goes to infinity? This is actually more general though, because x can take on different values. This can only take on integer values, okay, and it can only take on integer values, but here it can take on more. So this is a little bit different than this one is, but if this limit exists, then this one, it forces this one to exist, and it has to be the same as this one. Okay, do you guys remember what this limit is right here?
Isn't it 0? No, it's not.
No, it's not 0.
It's gonna be 1. Oh, that's also wrong. I feel like
That's not 1 either.
I don't remember.
You don't remember?
No.
Okay, there's a couple ways you can do this. One of them is, okay, so you're thinking of x is getting larger and larger, right? So the problem is that down here, this is going to infinity. That's also going to infinity. So if you wanted, you could use L'Hopital's rule. If you wanted. You guys remember that? L'Hopital's rule? But it's not really the most efficient way to do it. To do this particular problem. Because what you can do is you can multiply by a fancy form of 1, which will be 1 over x squared over 1 over x squared. You can multiply by that. And as you distribute that in there, you're going to get 5 over x squared plus 7 over 1 over x. Okay, so this comes in, and this comes in as 5. And as x gets larger and larger, then both this and this go to 0. And so you end up with 7/5, okay? And the same thing's gonna happen here. You're just gonna get 7/5. Okay, so hopefully that made some sense. That makes some sense to you guys?
Yeah.
Okay, so you could use this method, or you could use L'Hopital's rule. So take the derivative. Okay, yeah, so derivative of the numerator, that's 14x. The derivative of the denominator is 1 plus 10x. Take the derivative again. Yeah, 14 over 10, which is 7/5. Okay, so yeah, so it's been a while, but hopefully this starts coming back to everybody. Okay, let's move on. Number 6, determine whether the sequence converges or diverges. If it converges, find the limit. Okay, so here we have a different one. We have n squared over the square root of n cubed plus 6n. Anybody want to guess what's going to happen here? We could multiply by a fancy form of 1. Could multiply by 1 over n to the 3/2. Okay, 3/2 is 1.5, by the way. So up in the numerator, we'll end up with n to the 1/2, which is the square root of n. Okay, but as this goes in here, it goes in as 1 over n cubed. That's an n there, by the way. I don't know how it got changed to a 6. So we get that. I could write the square root of n. And of course, this is going to go to 0 as n gets larger. So you're taking 6 divided by n squared. That's dividing by large numbers. You make small numbers. And so what's the limit going to be?
The square root of n.
Yeah, and n gets larger and larger and larger. That's going to go to infinity. Yeah, because n is getting larger and larger.
Okay.
So you're taking square root of n divided by 1, basically. So that's not going to help to stop that. It'll go to infinity. It'll go to infinity eventually. So the answer is it diverges. Okay, number, any questions on that? Okay, let's go ahead and do the next one, number 7. Here we have -1 to the n over 6 times the square root of n. What do you think is going to happen to this one? Anybody want to take a guess? Okay, then this top piece is going to fluctuate between -1 and 1, right? But what happens to the bottom? As n goes to infinity, the bottom is going to 0, right? No, I'm sorry. The bottom is going to infinity. As n goes to infinity, the denominator is going to infinity. That means the whole thing
will go to 0 because it's
yes.
going to be a very, very big number on the bottom.
Yes, it's going to be 0. That will converge to 0. As a side note, this sequence right here, if you just have -1 to the n, so that'll be -1, 1, -1, 1. This diverges. This one diverges. Okay, but since we're dividing by stuff that goes to 0, then it goes to infinity, then the whole thing is going to go to 0. Okay, let's look at number 8. Determine whether the sequence converges or diverges. If it converges, find the limit. Okay, so you're looking at the limit as n goes to infinity. And this is factorial, okay? So what I'm going to do is I'm going to take this numerator. You have 5n minus 1 factorial. Okay, so now let me just note what factorial means. That means you take n, then you take 1 less than it and multiply it, and then you take 1 less than that and multiply it. And you keep going until you get all the way to 2 and then 1. Something like that, right? Okay, so I'm going to do kind of the same thing. I'm start with 5n minus 1, then I multiply by 5n minus 2, and then 5n minus, 5n minus 3, and I keep going until I get to 2 and then 1. I don't even need to put the 1 though. Here, the denominator is 5n plus 1. And if I subtract 1 from here, what do I get?
Just 5n?
Yeah, just 5n. And then I get 5n minus 1, right? And then I keep going.
Okay.
Down to 2, then 1. Okay, now if I look at this quotient, a very fun thing happens, right? Called canceling. It's like, this is real canceling. This is like mathematics canceling, which is much more fun than cultural canceling, right? And makes a lot more sense. Okay, so those cancel, and then these cancel, and these cancel. That cancels the next one. And then all these cancel with all the rest of those dots, and then the twos, and that's like that, right? Okay, now so then you're basically getting down to this right here. But then somebody else might say, oh, well, it's not really canceling, you're just reducing to 1. Yeah, and that's right, you're just reducing to 1. Okay. So we get that right there. So basically this limit is the same as this limit, which is going to be what?
Just 0?
Yes, it's going to be 0. Huh. I can't draw a smiley face. Darn it. Oh, well. It's just 0. I can make a big 0 though, I guess. Okay, number 9. Okay, so here we have the nth root of this. Okay. nth root is also, you can write that like this. So everything to the 1 over n, right? And then I'm just using properties of exponentials. This 1 over n can distribute to both of those. Okay, so divide that by n, I get 7. Divide 3n by n, and I get 3. Okay, now as n goes to infinity, what happens to the 7 over n?
It goes to 0.
See, there you go. You're catching on. So that goes to 0, and we're just left with 3 to the 3, which is 27. So great, that's the answer right there for number 9. Okay, number 10. If you have do you remember what happens if we have the difference of 2 logarithms? There's a property right here that if you take the natural logarithm of a minus the natural logarithm of b, that's going to be the natural logarithm of a over b, right? So 5n squared plus 7 over n squared plus 7. Okay. Now we can go through steps right here with this quotient right here, or we can just remember what happened in the past. These are both the same power, right?
Yeah.
The same order, too. That means that as n gets larger and larger, this is just going to go to
The natural log of 5.
5 over 1, which is 5, right?
Yeah.
That's just going to be log 5. And I guess the book wants us to put parentheses around this, so we'll do that. Okay, number 11. Determine convergence or divergence. Okay, so this is recursively defined. So here, an plus 1 is 6 minus an, right? And then per part a, a1 is 1. Okay? So if we take the formula and we set n equal to 1 in the formula, then that gives us a2. Okay, and that'll be 6 minus a1, which is 1, 6 minus. So that's going to be 5. Okay, and then if we set n equal to 2, that gives us a 3, which will be 6 minus, and we take the previous number, we take a2, which is 5, and we get a 1. Okay, so we can look and see what's happening with this. We're supposed to figure out if it converges or diverges. So the first term is 1, the second term is 5, third term is also 1. What do you think the fourth term is going to be?
5.
Yeah, it's 5. And then,
oh, nice.
Yeah, it's just going to go like that, right? Okay. So if it goes 1, 5, 1, 5, 1, 5 forever and ever and ever, does it converge or diverge?
Diverges.
Yeah, it's divergent. Okay. So this one, it's divergent. And that's it. Okay. So let's look at part B. So part B, you would think now, because this one, we're just using this formula here. This is the formula, right? We're just using our formula. And then this one diverged. Some people might think, well, this has got to diverge also. But let's take a look and see what happens. If we set n equal to 1, then that's going to give us a2, which is 6 minus A1. But this time A1 is 3, right? So that's going to be 6 minus 3, which is 3. Okay, so, whoa. Okay, so now if we start looking at what the sequence is, it's the first one's a 3, the second term's a 3. And, okay, the third term is also going to be, by setting n equal to 2, that's also going to be 3. And so here it's just going to be 3s forever. This is a sequence of all 3s. So that means it's convergent. Okay. It converges to 3. Well, it's kind of cheating because it's just 3 already all the time. So that's kind of weird. Okay, let's look at number 12, which is the final problem. So if $3,000 is invested at 8% interest compounded annually, then after n years, the investment is worth this much. Okay, that's according to, yeah, that's correct right there. So part A, find the first 5 terms of the sequence. So I'm gonna use green because this is money. Money and money's green, right? Or some money is green. So A1, just put a 1 in here. 3,000 times 1.08 to the first power. And I got 3,240. Okay, so that's the first one. A2, just put a 2 there. $3,499.2. The next one is 3,000 times 1.08 to the third power. Uh, 3,779.136, but you round it off to the nearest cent. And then A4. $4,081.47. And then A5, of course, is, so definitely have to use the calculator here. What is that, 0.98423? So 0.98. And then part B, is the sequence convergent or divergent?
Would it be divergent because it's going away towards from us?
Yeah, it's going to be divergent.
Okay.
So, but I don't know, in this case, I don't think that's relevant because you're not